Assalamualaikum and a very good day class. We're still under chapter 3, but for today we'll go to the direct method. In the direct method, you will learn how to solve small numbers of linear algebraic equation by using the first method is knife-Gauss elimination method, and then we will go to the Gauss elimination as partial pivoting, and also we have LU factorization method. In LU factorization method, it can be divided into three. The first one is LU as Gauss elimination, okay, LU as Gauss elimination method, and then we'll go to the Krauss method, and the last one is Kolesky method. So the expected outcomes of this topic by the end of this chapter or by the end of this subtopic, you should be able to transform a linear system or linear equation into matrix form. And then that linear algebraic equation, you need to know how can you solve it by using knife-Gauss elimination method, Gauss elimination as partial pivoting, and also LU factorization. So all these are the topics that will be covered in the direct method. For today's class, we'll go to the knife-Gauss elimination method. As mentioned previously, there are three types of method. So the first one is knife-Gauss elimination method that you will learn in this video. And then the next video will go to the Gauss elimination with partial pivoting. And then the last video will go to the LU factorization. And then class, what is meant by knife-Gauss elimination method? This method actually is a sequential process of you will eliminate unknowns from a system of equation by using, we have two steps here. The first one, we eliminate unknown by using forward elimination. And then based on this, you will solve your system using backward substitution. So involve two major steps in this knife-Gauss elimination. The first one is forward elimination and the second one is backward substitution. Generally, step by step is summarized here. For step number one, if you have a linear equation you can write in augmented matrix. What does it mean by augmented matrix? The augmented matrix is a matrix we only consider A matrix and also B vector. And then from here, you need to identify pivot element. And pivot element here is used as multiplier to derive row operation formula. I will go detail what does it mean by pivot element in the next slide. Based on this, we need to perform forward elimination to transform our matrix into upper triangular matrix. So here class, you have your matrix in terms of A and B, which is we write in terms of augmented matrix, and then you need to perform here forward elimination step so that we can transform this matrix into upper triangular matrix and a new vector P. What does it mean by upper triangular matrix here? Upper triangular matrix means that all elements below main diagonal should be equal to 0. So here if you have A11, A12, A13, here A22, A23, and then the last one A33 means that all elements below this diagonal, main diagonal, should be equal to 0. When we got this kind of matrix that is upper triangular matrix and a new vector B, then we can solve the system by using backward substitution. So how can we use forward elimination step? Step number one class, you need to rewrite a system of linear equation in terms of augmented matrix, which is as mentioned A matrix and B vector. For example, if you have this kind of system, means that we transform into augmented matrix that is here coefficient for all x. This is for the first equation become now A11, A12, A1n up to A and N, and this one here, okay, is our vector B, which is given by the equal of is all is B. So this is augmented matrix form. And then once we got the augmented matrix, we need to executing forward elimination of unknowns so that you can see here you will got the upper triangular matrix. But how to do this? You see, previously we have here, we have, for example, metric 3 by 3, we have for initially A11, A12, A13, A21, A22, A23, A31, A32, and then A33, and then we have B1, B2, B3. We need to perform forward elimination of unknown such that the element below this A11 become 0. For the first column here, we need to make sure A1, A21, A31 become 0. And this one, we call it as pivot element. Okay. And then for the second step, we need to perform forward elimination unknown such that the element below this A22 equal to 0. So now the first one, this one reduced to 0, this one reduced to 0. The second step, this one reduced to 0. When you have 3 by 3 matrix, means that now if this one 0, 0, 0, so it becomes upper triangular matrix. But of course, in that process, all A here, okay, sorry, all A here will change the, will have different value. The value will be changed because we transform this matrix into upper triangular matrix using row operation formula. So you will see later the value of A22, A33, A23, B2, and also B3 will be changed. How to do this? You have to base on this table, which is now this table refer to, you can see we have the first column is step, the second column is row, and then we have here multiplier, and then we have row operation. If you based on the step, we need to identify pivot element. What does mean pivot element? Element is referred to the value at main diagonal. That is, for example, if you have matrix 3 by 3, A11, A12, A13, A21, A22, A23, A31, A32, and A33, means that A11, A22, and A33 is our pivot element. But when we do forward elimination for the first column, means that this one will be changed. And also this one will be changed, means that we have the pivot element for the second step is not from original matrix. Okay, class. If we base on this table, for step number 1 here is referred to the column number 1, which is for column number 1, you have here row. For row, this I is referred to row, which is for column 1, row will become 2, 3, and so on. Means that in this case, our row become row 2 and row 3. This is our column number 1, which is referred to step number 1. Based on this one, the multiplier we need to calculate, which is equal to mi1 equal to negative ai1 divided by a11. Means that here when our I equal to 2 for the second row, so you will compute here m21 equal to negative a, this I we change to 2, negative a21 divided by a11. So that this one actually this value is equal to this a12. And then class, we need to perform based on this, we need to find row operation formula. Row operation formula is given by, for the step number 1, which is here referred to the column number 1, Ri plus Mi1 R1. That is, Mi1, if I here equal to 2, we have M21 equal to negative A21 divided by A11. So that here, this formula I is equal to 2. So R2 plus Mi2, M21 R1. Means that we have here R2 plus M21 is given by this negative A21 over A11 R1. This one will become a formula when we want to reduce A21 to 0. And then class, we have here row number 3. Row number 3 means that our I equal to 3. When I equal to 3, in this case, we will have here R3 plus M31 R1. I here we change to 3, but our M31 in this case will be equal to this one, M31, I is 3, equal to negative A31 divided by A11, which is this A31, okay? A31 actually is from our matrix, that is this one. Okay, this is A31, means that we will substitute A31, A11, means that you will get this M31 as value. So how to reduce this A31 to 0? We have to use this formula. Okay, and then when we go to step number 2, our I now become 3 and 4. Why? Because step number 2 is happened at column number 2. For column number 2, we want to reduce A32 to 0. That's why our I will start with row number 3. It is not row number 2. And then the rest will be same. And class, finally, when you have n, I equal to n, this is the general formula of multiplier and this is the general formula of row operation. I will show you it is become easier for you to understand this table if you do a lot of exercises, and then class you can automatically remember about the multiplier and row operation without referring to this table. After we did this step, after we did the forward elimination step, we need to do backward substitution step. Backward substitution step means that once you got a matrix of, in terms of upper triangular matrix, means that we have, for example, 1, 2, 3, and here becomes 0, 0, 0, 4, 5, and 6. Why this one becomes 0, 0, 0? Because we already transformed from previous step using forward elimination of unknown. Let's say we have here our vector B, 1, 2, 3. So what does it mean by backward substitution? Backward substitution, actually you will start with the last row, you change back into equation, then you will solve it for unknown. That is here, when we change back this one into equation, we will have here 0x1 plus 0x2 plus 6x3, which is equal to 3. So the unknown here that we want to solve is actually x3, means that x3 will be equal to 3 over 6. This is the purpose why we need to do forward elimination step, so that all elements here become 0, then we can solve by using backward substitution method. And then class, when we want to solve, when we go to the second row, because it is backward substitution, you start with the third row, you go to the second row next, then you go to the first row. For the second row here, we have 0x1 plus 4x2 plus 5x3, which is equal to 2. So x3 we already got here, so you can substitute x3 with 3 over 6. Means that 4x2 equal to 5 plus 5, 3 over 6 equal to 2. Means that now you only have x2 as your unknown, so that you can solve for x2 using this equation. And then the same thing happened for the first row, means that we will substitute our x2 and x3 that we got from third and second row, then you can solve for x1. This is how we can use backward substitution method. This example asks us to solve the following system of linear equation using knife-Gauss elimination method. So class, all the solution is provided here. However, to make sure you understand well, let's now we do this example step by step. So for this one, the first step, we need to write our matrix into augmented matrix. So we'll have here, remember, all coefficients of the unknown will become a matrix. 4, 3, 2, 2, negative 1, 1, 1, 1, 3. And then in augmented matrix, this is our A. And then we have here 13, negative 1, 14. When we want to reduce into upper triangular matrix means that your aim here, you will need to do forward elimination method. And then you will have here your upper triangular and your new vector B. Based on this, how can we do this one? So class, remember our step number 1. We have here I equal to 2 and 3. Because now we have 3 by 3 matrix. Remember, we need to reduce 2 and 1 to 0. And then the multiplier here is given by mi1 equal to negative ai1 divided by a11, which is here when we have 2 and 3, so that, for example, I start with the row number 2, I will have here m21. This is for I equal to 2 equal to negative a21 divided by a11. That is here our a21 is given by 2. So it is negative. So negative 2, a11 is 4. So we have here negative 2 over 4. And then class, based on this, you need to find your row operation formula, which is row operation formula is given by Ri plus mi1 r1. So here we have for I equal to 2, so that r2 plus m21 r1 means that r2 plus here m21 is negative 2 over 4 times r1. This one refer to row 2, this one refer to row 1. You have to write in terms of R2 and R1. We cannot substitute with the formula. We will see later why actually we need to write in terms of it. And then class, if we have I equal to 3, so you will have here M31 equal to negative A31 divided by A11. That is equal to negative, our A31 is 1. This is A31, this is A12. So negative 1 divided by A11 is 4. And our row operation formula, it is Ri. I now is 3. So that it is R3 plus M31 R1. Means that here R3, we have R3 plus negative 1 over 4 times R1. So in this case, you will have the formula for the first step. This is your row operation formula for R2, and this one is row operation formula for R3. And how can we solve this one? We have here, we write again our augmented matrix, that is 4, 3, 2, 2, negative 1, 1, 1, 1, 3, and then we have here vector B, 13, negative 1, 14. When we perform here row operation, we'll got based on previous, what we did here, we have R2 plus negative 2 for R1. So this one is a formula for row operation that is referred to row number 2. And then you write under this arrow, the row operation formula for row number 3, that is R3 plus negative 1 over 4 R1. When we have these two formula class, what we need to do here, we need row number 2 and row number 3 will change. The value will be changed. But for row number 1, we did nothing. So here, we have the same values for row number 1, which is 4, 3, 2, and 13. But for row number 2, we have this formula, this R2 that is referred to row number 2. Okay, we start here with the first column, which is for the first column, we take R2 here, the value is 2. So it's referred to 2 plus negative 2 over 4. This one fixed. And R1 is referred to the value above this one. Means that value of A11 at the first column. That is, we multiply with 4. When we cancel out, we'll got 0. If you not got 0 for this one, means that there is something wrong in your formula. Because our purpose here, we want to make sure the value below this pivot element all equal to 0. So now we got 0 for this one. And then when we change for the first value here, you need to change for all. Means that for the next one, the R2, the value is given by this negative 1. Negative 1 plus negative 2 over 4, and R1, the value at the first row but above this negative 1, which is 3. So times 3. When we solve this one, class, you will got the answer equal to negative 5 over 2. So here we have a new value that is negative 5 over 2. And then we did it for the next column, that is third column, but still at row number 2. Remember, class, you need to finish for all elements here. Then you can proceed to the next row. So here, we have for this R2, the value is 1 plus negative 2 over 4 times 2. Means that here 2 comes from this value. Okay. When we solve this one, we'll get the answer. This one is, we can cancel out 2, 1. So here we can cancel out. So 1 minus 1, we got this one equal to 0. Means that the value here is 0. Then we did for the next one. Also, you need to change for B. You cannot just change for A matrix. Because if you didn't change for B, you will got wrong answer. So plus for B, we have here negative 1 plus negative 2 over 4, and you need to times with 13, because here the value of the R1 here, this R1 is from row number 1, should be this 13. So when we solve this one, class, we'll got the answer equal to negative 15 over 2. Means that here negative 15 over 2. And then the rest value here. For this one, for row number 3, we did the same way. Okay, we did the same way as what we did for row number 2, but now we use here this formula. How to do that? This is R3. R3 means that now we go to row number 3. When we go to row number 3, for the first column, we have here 1. Means that 1 plus negative 1 over 4, okay, times here R1. R1 refer to a value of at row number 1, but for the same column, which is time 4. When you cancel out this, 1 minus 1, you will got equal to 0. So now we got equal to 0, means that our formula is correct. If not, make sure you check your formula. And then when we go to the second column, so now 1, we have 1 plus negative 1 over 4 times here R1, you have to refer to this column, we have 3 as its R1. Means that here, class, we times this one 3, so we'll got the answer, this one equal to 1 over 4. So this one equal to 1 over 4. Then we will go to the next one, that is 3. R3, the value for this third column is 3 plus negative 1 over 4 times R1, the value is 2. Okay, when we solve this one, we got equal to 5 over 2. So this is 5 over 2. And please remember that you need to do so for B vector, which is here we have for this one, this R3 is 14 plus negative 1 over 4, which is time here 13. So we'll have got the answer equal to 43 over 4. So now the answer is 43 over 4. Means that, class, you have now new augmented matrix. But it is not yet finished, because your final output here, you need to reduce your matrix into into upper triangular matrix. That is, now we want to change this 1 over 4 to 0. Then, class, when we go to step number 2, that is, you want to make sure this 1 over 4 equal to 0. So now we have our I equal to 3. That is, I here is at row number 3. If you refer back to the table, it is Mi2 equal to negative AI2 divided by A22. So in this case, we have negative AI is 3. 32 divided by A22. But A22 here, remember, class, it is our new value. This one. It is not, you cannot refer back to your original matrix. You have to base on your new matrix. So we will have here equal to negative 1 over 4 divided by negative 5 over 2, which is equal negative 1 over 4. This one we can multiply here when we move this one up. So we have here negative 2 over 5. That is equal to 2 over 20, which is equal to 1 over 10. So now our row operation formula, that is we have here, we want to change row number 3 plus this multiplier, that is plus m3 2. So we have here e plus this I is 3. 1 over 10 times now R2. What we did here now, we will continue from here. That is, we will have here a new operation, which is this operation is used to change the value at row number 3. So we have R3 plus 1 over 10 times R2. And then class, based on this, you will got your new matrix. That is, when we change this one, we will have the first row not changed, 4, 3, 2, and here 13. The second row remains same also, that is 0, negative 5 over 2, 0, negative 15 over 2. But here now we do row operation. Okay, I write here. We do row operation for row number 3. That is, for row number 3, we use this formula. For the first element here, that is 0 plus 1 over 10. You times, okay, this 0 plus 1 over 10, this multiplier, you times with R2. R2 is also 0, so you got this one equal to 0. Make sure, class, this one you got equal to 0. If it changed back to the value, there is something wrong in your formula. And then next, row number 3, which is 1 over 4 plus 1 over 10, you multiply here with negative 5 over 2. So now we got here this one, we cancel out. This one become 2, this one 1. Okay, so negative 1 over 4, you will got 0. Now we got this one 0. And the next one, we have here row, we need to change this element, that is row number 3, this one 5 over 2, okay, plus 1 over 10, which is our multiplier, times R2, so times 0. So we'll got the answer here 5 over 2, that is here 5 over 2. And remember, class, we also need to change the B element here, that is, for this B element is become 43 over 4 plus 1 over 10, which is time here R2. So you should multiply with this negative 15 over 2. So we got here negative 15 over 2. When we solve this one, we got equal to 10. That is, the answer here is 10. If you see here, now you have your new matrix, that is now it's become in upper triangular matrix and a new vector B. Means that from here we have the matrix 4, 3, 2, 0, negative 5 over 2, 0. And then we have 0, 0, 5 over 2. And then for our new B is 13, negative 15 over 2, and 10. So now we have a new augmented matrix. We can proceed with step number 2, which is backward substitution. Remember, in backward substitution, we need to change in backward substitution, we need to change all row in this matrix into equation. That is, we start with the last row we have here, 0x1 plus 0x2 plus 5 over 2x3 equal to 10. So when we solve this one, we have here x3 equal to 10 times 2, which is divided by 5. So we will have here this one 1, this one 2, which is equal to 4. And then class, we go to the second row, we have negative 5 over 2x2, but all this 0, which is equal to negative 15 over 2. So our x2 equal to negative 15 over 2 times negative 2 over 5. Means that we can cancel out this, also this one. So we now got equal to 3. And then we can solve for x1, which is for the first row, we have 4x1 plus 3x2 plus 2x3, which is equal to 13. So in this case, our x2 and x3, we got it from here. So we can substitute. We have here 4x1 plus 3, x2 is 3, okay, plus 2, which is x3 is 4, which is equal to 13. When we solve this one, you will got the answer. Your x1 will be equal to -1. Means that here, class, we got our x equal to our x1 -1, x2 is 3, and then our x3 is 4. This is the final answer. Means that now we have solved the problem by using knife gauge elimination method. And remember, it's involved two major steps, which is forward elimination and backward substitution. In forward elimination method, you have to find your multiplier, and then you have to do row operation such that you got the upper triangular matrix and new vector B. And from here, you can solve it by using backward substitution. So class, this is how you can use knife gauge elimination method in solving linear algebraic equation. Thank you for your attention, and see you in the next video to see how can we use partial pivoting in solving this kind of problem.